we are going to compare properties of multiple functions, each represented in a different way. So what we have here is we have a graph called a of x right there. So let's label that a of x, just so we have things labeled. All right, and we have a function b. We have a sentence here describing c, and we have a table of d. What we're going to do is we're going to compare all four of these functions, a, b, c, and d, and then ask some questions about them. In order to compare them, what you need to do is change them all into one type. You have to change them all into tables, or all into equations, or all into sentences, or all into graphs. So if we look at these questions and kind of think about them, what's the best type of description of the function so we can make comparisons? Probably a graph. A graph is usually the best one to compare four different functions. So what we're going to do here is we're going to graph all four of these. Well, A is done. So we're going to graph these three so that we can then go and compare them with what's asked of over here. So let's graph B. To graph B, hopefully you realize your HK is 0, 5, and your A equals -2. So if I go to 0, 5, which is right here, put my dot, and then I go over 1 and then down 2, and then I go over 3 and then down 2, I will have my square root graph for that, and I'll call it b of x. So I just graphed b. Now I can compare those two, but let's keep going, because I want to now graph the rest of these. So for this sentence, I have another square root function with a +4 lead coefficient, a vertical shift down of 5, and a horizontal shift right of 1. So let's write down our AHK for this one. For HK, well, if it says a vertical shift down of 5, wouldn't that mean your y value is a -5? And a horizontal shift right of 1, wouldn't that be a +1? And if we need our a value, what's our a value? Well, isn't that the lead coefficient? And isn't it a +4? So if we take those pieces, put them together, we now have our a, h, and k, which we can now graph. I'll do 1, -5, which is right here. A value of 4 means I'm going to go over 1 and up 1, 2, 3, 4. There's my dot. I'm going to go over 3 and up 4 again. So 1, 2, 3, 4. And that right there becomes your third graph, which is c of x. Alrighty. Now let's do the last one. It's a table. And a table is actually the easiest, because plot the dots. All right, one thing I didn't tell you here, assume it's a square root. I should have told you it's a square root. That's a little bad, because when you plot these dots, like, what is it? But let's plot them. -3, -2. So where is that? -3, -2, -3 right there. So we have a dot right there. All right, -2, -3. So -2, -3 would be right there. 1, -4 would be right there. And 6, -5 would be right there. And you hopefully can also see kind of like it's a square root look. But there we go. There's our third graph. And we'll call that d of x because that's what it's called. We'll label it, I should say. So we have all four functions now in one way to compare. So now we have all the functions. Let's go on. Which function has no x-intercept? So that means which one does not cross the x-axis. Now, you might think B never crosses the x-axis. Well, in the picture, it doesn't. But later on, will it at some point cross? Won't this line keep going down, 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 down to cross at some point over here, like beyond? So B will cross. Some people say, B of x. No, no, no. It does cross later. Now, the one that doesn't cross, can you see how D will never cross? It will never come back up. It starts below, and it's never going to come back up. So hopefully you can see that is going to be d of x. All right? I don't think all the rest will cross or have crossed already. Which function has the largest y-intercept? Y-intercept means where it crosses the y-axis. So let's see, the largest y-intercept would be, well, the red never crosses the y-axis, so that's not even a chance, because it starts here and it goes right. This one's way down here. Isn't the blue one here have the highest, largest y-intercept? Yeah, Even though it starts there, that is still the y-intercept. So what is that? That's b of x. So my next answer is b of x. Let's keep going. Which function has a domain of -3 to 1? Now, like this black one goes from -3. Oh, I said that wrong. -3 to infinity. I said that wrong. The black one, doesn't it have -3 to infinity? Yeah, but isn't there stuff left of -3? So it's not the full domain. Okay. Isn't this green one start at -3 and go to the right forever? Isn't that the graph that starts at -3, that's what that means, and goes right forever? So that looks like the green one. So we'll go with d of x. That one has that domain. Next, which function has an average rate of change of 1 on -4 to -1? All right, so from -4 to -1, let's see, where would that interval be? Let's think about this for a second. From -4, it's right there, to -1. That's my interval. All right, that's my interval. So we're looking in this little interval right here. So first of all, we have to think which graphs actually exist in that interval. Well, the only one that is the black one. Isn't the black one the only one that even exists in that interval? The green one doesn't fully exist there. So it can't be the red, it can't be the blue. They don't even exist in this interval. So it has to be the black. Let's double check to make sure the slope is what they said. Let's see that. Let's see, what did my slope get? Are we going up and over? Isn't my slope giving us a +1? Aren't we going up 3 and over 3, which isn't that a slope of +1? Okay, so that would be, looks like a of x, my black one. Now, this one was a little overly easy because they actually gave you the only one in the interval. Now, if we said a different interval, you'd have to check them all. Like if I went from 1 to 3, you'd have to check all of them. So be careful on that. All right. Which functions are increasing? Those plural functions are increasing. So increasing means they're going up as you go to the right, which that looks like the black one and the red one. So a and c. So that looks like a of x is increasing, and so is c of x. Those are the two there. All right, next one. Which function has a vertical stretch of 2? Doesn't vertical stretch mean a of 2? Okay, what is the vertical stretch for this one? Well, I go over 1 and up 1, 2, 3. So it's not that one. This one's over 1 and down 1. No. This one's over 1 and up 1, 2, 3, 4. No. This one's over 1 and down 2. Well, that's a -2, but wait, isn't the vertical stretch doesn't care about the negative? Isn't the negative a flip? So doesn't this blue one actually have a vertical stretch of 2 just upside down? The negative just is describing up or down. It's still a vertical stretch of 2. So it is actually b of x. For a second I thought it might be nothing. But b of x is a vertical stretch of 2 with a negative in front when you actually graph it. It's a flip, a reflection. Lastly, let's write the equation for d of x. So right here, d of x, we got from this table. Let's write an equation. So to write an equation, well, first of all, let's think what a is, and let's think of hk. So hk looks like it's -3, -2. All right? And your a value, well, when you go over 1, aren't you going down 1? So what's your a value be a -1? So can we put that together to make the equation of d of x? D of x is equal to -1. We know it's a square root. The opposite of -3 is going to be a +3, and we put the -2 at the end. Again, we always take this x value, put it next to the x opposite, and we take the y value, put it at the end. And that would be the equation of d.